Hey Brandon, so we're going to scroll through this work we did on practice number 2. You're going to hear a little noise in the background. We have a crew over here working on our house. So starting here with problem number 4, section 3, we look at that expression and see that the first and the last term are perfect squares. And so we're just going to check to see if maybe it is a perfect square, which it is, 3a squared plus 2b squared, the quantity squared. We have this number 5, a square root problem. Put the x on the right, and you can square both sides. Number 6, look for similar triangles. And then we have combining exponents in number 7, and factoring that difference of two squares. Number 11 is rationalizing that denominator of complex fraction. And you'll see what we did there. Number 12 is just solving that equation for f. Number 13 is the special thing which is useful in the SAT math about if you have a quadratic with the leading coefficient of 1, you can recognize the sum of the roots is the opposite of the middle coefficient. And if they ask for the product of the roots, it is the last coefficient, including the sign. Number 15, we can find out the remainder easily when we do that division, 5x minus 2 divided by x plus 3. By just plugging in the 0 of the denominator into the numerator, we find out the remainder is negative 17, and the only place negative 17 shows up is in choice D. Number 18, similar triangles again. Number 17, we're looking for B, which is the coefficient of x on the right. So all we have to do is find out where the x terms come from on the left, and we total them up, and it's 19x, therefore B has to equal 19. In general, that phrase, if the equation is true for all values of x, it means the coefficients on the left equal the coefficients on the right. And number 19, we have to look for that special right triangle and recognize that it's a 30-degree angle, which is pi over 6. Number 20, again, if the system has infinitely many solutions, means those two linear equations are the same line. So we can find the value of a over b just by looking at the one with numbers, 2x plus 8y equals 60. So we can do the x coefficient over the y coefficient easily there to find that it's 2 over 8, 1 over 4. On to section 4. This is number 10 is function notation, function operations. It's just careful substitution from the inside out. F of g of 3, first we find out what g of 3 is, plug it in for that, then we have the f of 2, which is 3. So I'm going to stop this now and get the rest to you later.